Assalamualaikum warahmatullahi wabarakatuh. I'm from group 1, will be represent exercise 1.5 number 2, which is Fourier cosine series. Our group members is NAYLI binti RAHZANI, Iryani binti Rodzi, and NURUL binti MOHAMMED Anas. In this question, we need to sketch the predict function of ft, t plus 1, negative t plus 1, with the interval negative 3 to 3. And we need to determine the function which is odd, even, or neither function. So the first step to solve this question is we need to sketch the function to determine whether it is odd function, even function, or neither function. So from the equation ft, we can determine the coordinates for the waveform by insert the value of t into the ft. So we got the coordinates for negative t plus 1 is negative 1, 0, 0, 1. And for function negative t plus 1, we got the coordinates of 1, 0 and 0, 1. So here is the waveform. But from the question before, it stated that the interval from negative 3 to 3. So we need to expand the waveform from negative 3 to 3. So from the waveform, we see that the waveform is actually symmetric on the y-axis. So we know that when the waveform is symmetric at the y-axis, it is even function. So for the even function, we do not have to calculate like a neither function, which is a0, an, and bn. So for even function, we only have to calculate for a0 and an, and the bn is equal to 0. So next one is we need to calculate the a0. A0 with the formula of 2 over L with the L0 integrate to ft dt. So we got that L is 1 and the limit from 1 to 0. So how we know L is 1 is because of from the interval itself. So L equal to 1, so the period 2 times L, so 2 times 1 equal to t. So we see here negative t plus 1, we integrate, so get negative t squared over 2 plus t. So we insert the limit into the equation, so we get negative 1 over 2 plus 1. So as we see that a0 is equal to 2 over L is equal to 2. So negative 1 over 2 plus 1 is equal to 0.5. So 0.5 times 2 equal to 1. Next, after we had calculate the a0, we need to calculate the an. So the formula of an is 2 over L with the limit of L0 with the function of ft times cos n pi t over L dt. So we insert the equation, it will become 2 over 1, 1 with a limit of 1 to 0, negative t plus 1 with cos n pi t dt. So I am using the tabular method to solve the integration. So I get this equation, which is 2 times t plus 1 sin n pi t over n pi plus cos n pi t over n pi squared. Need to insert the limit from 1 to 0. So after we had insert the limit into the equation, we got 4 over n pi sin n pi plus 2 over n pi squared times cos n pi. So from minus 2 over n pi sine 0 plus 2 over n pi squared cos 0. So we know that sine n pi is equal to 0, cos n pi is equal to negative 1 to the power of n, sine 0 is equal to 0, and cos 0 is equal to 1. So after we solve it, we got 2 over n pi squared times negative 1 to the power of n minus 1. So next we insert the value of a naught and an into the function ft. So the formula for ft for Fourier cosine series is a naught over 2 plus an times cos n pi t over L dt. So a naught is equal to 1, so 1 over 2 plus an 2 over n pi squared 1 plus negative 1 to the power of n plus 1 times cos n pi t. So this an is a little bit different from the an I had written before. This is because I'm using the formula of this which is negative k times negative 1 to the power of n. To remove the negative in front of negative 1 over n is equal to negative 1 to the power of n plus 1. So from this all an 2 over n pi squared, so I put 1 in front, so it will become 1 minus negative 1 over n. So to remove negative negative times negative 1 to the power of n, so I'm using this formula. So it will become like this, 1 plus negative 1 to the power of n plus 1. That's all from our group. Thank you.